All right, Jen, I'm going to assume that's your name here. You asked me a few questions. I figure this might be the easiest format to answer them. So, first thing, we're talking about SOCl2 or thionyl chloride here. And SOCl2 can react with alcohols, and you kind of already pointed out that you knew this, but I just want to kind of go over everything here. And it can replace the alcohol of a primary or secondary alcohol with, whoop, that's supposed to be a chlorine. It does the same thing on a carboxylic acid's hydroxyl group over here as well. So, and we can replace that hydroxyl group with a chlorine there to making it acid chloride. Those are the two big times you're going to see SOCl2 used. It is simply a substitution for an OH, whether it be an alcohol or carboxylic acid. Now POCl3 on the other hand, so this is used for doing an elimination reaction of an alcohol. This is the first place you'll see it come up. So we'll find out it can also, notice that's a dehydration. You're going to lose the OH, and then on the adjacent carbon you'd also lose an H. So it's technically a dehydration. So it's an elimination for an alcohol, but also dehydration. We'll see there's another dehydration with amides it can do as well. The reaction you gave me involved cyclohexanone here with a Grignard first and then POCl3 second. So if you look at Grignard, great nucleophile here, right? And this nucleophile come attack the carbonyl, so attaching a methyl group. And technically we'd normally do this in two steps. So, and add a little bit of dilute acid in the second step, leaving us with an alcohol. So we've now attached the methyl group, but now we also have an alcohol. So now once we have an alcohol, POCl3, like it did above, will do an elimination. So at low temperatures, we can actually get this to go Hoffman or anti-Zaitsev, but it's just going to go Zaitsev and form the most substituted alkene possible, which would be this guy. So, and that's why it formed an alkene in that case. If we look then, the other one you talked about was the amides, and you're saying, with the amide, if we added SOCl2, so why didn't it form a carboxylic acid? If you recall in the chart, the only time SOCl2 was ever used was for this reaction up here, converting a carboxylic acid into an acid chloride. That's the only time we saw it on that chart. So the reaction down here, this is actually not part of the chart I gave you. This is an extra reaction your professor or textbook's thrown in there. And whether we use SOCl2 or, more commonly I've seen it with POCl3 here, we can turn an amide into a nitrile. So it's one of those extra reactions. Most classes would not be presented this one. It's one of those extra ones your professor knows and is throwing in there. Hope this helps.